Hello everyone. This is an introductory video on physically based rendering. We'll understand what this term means, what material, workflow, textures, and more are. This is a basic video tutorial aimed at those who are not at all familiar with the fundamental concepts of physically based rendering and want to learn them before starting to use Substance 3D Painter. This tutorial was made using version 7.2.1 of 3D Painter, but the concepts expressed here have been valid for several versions of the program and, indeed, apply to physically based rendering in general, even in other software, as we will see. If you are here, you probably already know that Adobe Substance 3D Painter is a program that allows you to create materials and textures for 3D models. The 3D model files are then imported into Painter, and here, it is possible to create texture images, map them onto geometries, and export such images. The thus textured object can be used in game engines like Unity or Unreal to create video games or even virtual or augmented reality applications, or in animation and rendering software like Blender, 3D Studio Max, Maya, or even real-time 3D viewing systems on the internet like Sketchfab and more. Before starting to explore the software interface and use its tools, it is therefore necessary to define what a material is in 3D computer graphics. A material is a set of information that, when given to a 3D object, defines how it will behave when illuminated and rendered in a virtual scene. Rendering, that is, the final image visible on the screen both in a precalculated way and in real time, is indeed the result of the interaction between light and surface in a virtual scene, so we need to take into account light sources and surfaces or, in some cases, the volumes of objects. To this first result, it's possible to add post-production, but, as the name suggests, these are actually effects and filters applied after the actual rendering, so we won't talk about it for now. Okay, so a material is a series of information, but what is this information? Depending on the theoretical model, also known as scheme, method, or paradigm, used for rendering, it is possible to specify various types of information, each with its own characteristics. Substance 3D Painter, in particular, allows us to define materials that follow the physically based rendering model, or PBR for short. Sometimes you might also come across PBS, which stands for physically based shading, referring to the shading of object surfaces, of course. In this tutorial, we'll see what they are and, above all, how the fundamental textures that we need to define a PBR material in Painter combine with each other. We need to understand these things to create and customize our materials confidently, without guessing as we modify the parameters of this or that information channel of a material. To avoid making this tutorial too theoretical and boring, I will talk about the fundamental elements of PBR and how they translate into Substance Painter using a 3D model already provided with materials and textured in this program. This is one of my 3D models, Wooden Barrel. You can find the link to the model in the description of this video, but it is not absolutely necessary to have this 3D model to learn from the tutorial. The physically based rendering paradigm is based, as the name suggests, on a physical approach, that is, on what happens in the real world. It's possible to specify materials with two work methods, called workflows, which are metallic and specular. In the case of the metallic workflow, surfaces are distinguished between metallic and non-metallic, and based on this distinction, all the other channels behave differently. In the case of the specular workflow, on the other hand, the intensity and possible color tint of specular reflections are defined to determine how the light interacting with the object's surface will behave. Specifically, in the metallic work method, used in this example, the appearance of a surface is given by some characteristics, the most important of which are its nature, in particular, first distinguishing whether it is a metal or a non-metal, also known as a dielectric. Its base color, precisely called base color, which in a metallic object indicates the intensity of light reflections, while in non-metallic objects it actually indicates the base color of a surface without lighting effects. The roughness of the surface in its various points, or conversely its smoothness, called glossiness. To these characteristics, observed in the real world, some are added that come in handy in the virtual world. For example, by using particular texture images like normal maps or height maps, it is possible to simulate the presence of details without modeling them on geometries, so as to save vertices, edges, and faces. A simpler geometry will save computing resources in the rendering phase, especially in video games and other real-time applications. The wooden barrel that I'm using in this video allows us to examine, in a single object, how these basic pieces of information translate into textures and combine with each other in a substance material. To preview the complete material applied to the object in the 3D window, I press the M key, short for material, or I choose material from the drop-down menu at the top right in the 3D window. As you can see, we have both metallic elements in iron and non-metallic ones in wood. This will allow us to appreciate the differences with which these two types of materials are treated, in the definition of their base color and the colors of the specular reflections, with the PBR method. To view the individual information channels, which translate into as many texture images applied on the object's surface, we can press the C key multiple times or choose the channel we're interested in from the drop-down menu at the top right in the 3D view. Let's start with the metallic channel, which defines which parts of the material to treat as metallic and which not, particularly through a grayscale image, where white is used for pure metal and black for pure non-metal. In the case of the barrel, we also have intermediate grays because the material used for the metallic parts, called iron old, should represent old, worn iron, maybe with some dust or rust that lowers its metallic nature, so to speak. The wooden parts appear, instead, absolutely black or non-metallic, as it should be. Let's move on to the second fundamental channel of PBR, namely base color. As you can see, this information channel presents the base color of the object through a color texture, without lighting effects or shading. These are flat textures, so to speak. The colors of the metallic parts and the wooden parts have similar intensities. The color is different, but they don't seem so radically different in appearance, even though they belong to completely different substances. The reason is that the distinction, during shading and rendering, is made by substance using the metallic texture, which tells substance that light reflections need to be managed differently depending on whether they relate to a metallic or non-metallic surface type. The gray points of the base color of the metallic parts indeed define the intensity of the light reflections and the possible color tint to give to such reflections. The iron-old material is a dirty material, so the effect is not appreciated much, but look how things change, in the various channels and in the final result, if I insert a material of aluminium pure type of substance between the wood and the metal material and if I disable the underlying iron-old material. In the final result, the metallic parts appear much more reflective than before. In the metallic channel, the metallic parts are in pure white, it is very pure metal. In the base color channel, the metallic parts are almost white. This means that in those points the intensity of the specular reflections will be maximum and there will be no color tint. Now look what happens when bringing the value of the metallic parameter of aluminium pure to 0. The metallic rings have turned white, they no longer reflect as before, they seem like objects made of white plastic. Now let's bring metallic back to 1, but lower the value of base color. Now the rings retain the reflectivity typical of metal, but become increasingly darker. The point is this: in the metallic workflow, like this one, the base color of an object is not enough, on its own, to define how reflective a surface will be, because it must specify whether it is a metal or not. In a metal, the intensity of the base color is also the intensity of the light and specular reflections, while in a non-metal, the base color only defines the surface's own color, as happens on the wooden parts of the barrel. Now I leave the aluminium pure material activated and iron old deactivated to show you the effects of the third fundamental channel of a material, namely roughness. Roughness, opposite to smoothness, is represented with a grayscale image, just like the metallic texture, but in this case, white is the maximum roughness, while black represents a completely glossy, perfectly reflective surface. In fact, a perfect mirror is implemented in PBR with a metallic material with pure white color and roughness set to 0, as I am showing on the video right now. By increasing the roughness value, we will make the surface less smooth and, therefore, its specular reflections more diffuse or blurred. This applies to both metals and non-metals. Now I am removing the aluminium pure material and reactivating iron old to return to the original configuration of the project and take a look at some extra information that, in computer graphics, allows adding details to surfaces during rendering, that is, without having to physically model them on geometries. I select the normal height mesh option from the selector in the upper right corner of the 3D window. This view shows the combination of multiple information channels that influence the simulated details on the surface of an object. Without these details, the surfaces of the object would appear smooth, not very believable, especially in the wooden parts. In particular, in the example I am showing, the surface details are mainly implemented, in the wooden parts, by the fibers layer. To observe the differences in the appearance of the surface with and without this information, it is sufficient to deactivate the relevant elements in the Layers tab, observing the differences both in normal height mesh mode and in material mode, in the 3D view. The differences become more evident if the object is illuminated with oblique lighting, rather than frontal. Effects of this kind are also present in the metallic parts, implemented through the height and normal information channels of two iron old layers, namely iron and edges. As can be seen, these textures make some surfaces much more interesting which, in their absence, would end up being implausible, because they are too smooth or flattened, in a sense. To recap, a material is a set of information, implemented through images, some in grayscale, some in color, that are mapped onto the surfaces of objects and combined together according to a criterion, which in our case is the PBR metallic paradigm. This information defines the way in which the object's surface and light sources interact to produce the final image. PBR is based on characteristics of materials observed in the real world and implemented in computer graphics by appropriately combining textures that represent these characteristics. The PBR method involves two workflows, metallic and specular. In this tutorial, we have seen an example following the metallic methodology. In the PBR metallic method, we first have to define, using a grayscale texture, whether parts of a surface will be metallic or not. Base color is a color texture that, in the metallic parts of the surfaces, defines the intensity and any color hue to be given to specular reflections. In the non-metallic parts of the surfaces, base color is only the surface's own color, without lighting or shading effects. Roughness indicates the degree of roughness of a surface. With low roughness, the reflections will be very well defined. In fact, in a metallic surface with a base white color, the material will behave like a perfect mirror, while as this value increases, the light reflections will be increasingly diffuse and blurred. Each point of the roughness texture is associated with a numeric value between 0 and 1. This value is complementary to that of glossiness, which represents the glossiness or smoothness of a surface. When roughness is 1, then glossiness is 0, and vice versa. Normal textures are color images that, along with grayscale height textures, allow to simulate the presence of details on surfaces in the visualization and rendering of objects. They are useful for saving geometries and, therefore, computing resources, especially for real-time applications like video games or virtual or augmented reality apps. Well, for this introductory video tutorial on the basic elements of PBR, materials, and textures in Painter, we stop at these first 4 information channels. I invite you to express doubts, observations, and requests in the comments to the video on YouTube. See you soon!